In question number 16, two identical particles moving in opposite direction with de Broglie wavelength lambda 1 and lambda 2, with lambda 2 is greater than lambda 1, combine to form a single particle with de Broglie wavelength lambda. The value of lambda is, well, lambda 2 is greater than lambda 1. It simply means the momentum of first particle would be greater than second one, if this is P1 and this is P2. So I would say the total momentum is P1 minus P2 would be P. From here, h by lambda 1 minus h by lambda 2 must be equal to h by lambda, or lambda 2 lambda 1 must be equal to 1 by lambda, or lambda is equal to lambda 1 lambda 2 divided by lambda 2 minus lambda 1. So this is the required answer here. So for question number 16, our answer is option 1. That's the correct answer. Now let's proceed to question number 17. The nuclear binding energies of element A and B are E1 and E2 respectively. Two nuclei of B fuse to form one nucleus of element A. The energy released during process is E. The correct relation between E1 and E2 is, very simplest of the question here. If two nuclei of B fuse together to form one nucleus of A, then energy released in this process will be written down as the binding energy of this part minus twice of binding energy of this portion. So it would be E1 minus 2E2, or I would say E plus 2E2 would be equal to E1. So for question number 17, option 3 is the correct answer. Now let's proceed to question number 18. Here in question number 18, the current flowing through the Zener diode in the circuit zone is, this being the circuit, the Zener diode is connected across this point. Breaking voltage being 4 volt, so here the current I1 across the 1 kilo ohm resistance, it would be 4 divided by 1000 ampere, and the potential difference across these 2 points will be 6 volt. So current across here, it is I is equal to 6 divided by 1200. So the effective current across the Zener diode, it is I dash is equal to 6 divided by 1200 minus 4 divided by 1000. Making the calculation, we'll be getting this answer as 1 divided by 1000. That means I dash is equal to 1 milliampere. For question number 18, option 1 is the correct answer. Now let's proceed to question number 19. In question number 19, for an amplitude modulated wave, the maximum amplitude is 8 volt and the minimum amplitude is found to be 4 volt. The modulation index is, without any calculation, let's have the elaboration itself. If this being the average value here and it is oscillating like this way, it's been said that this part maximum value to be 8 and the minimum to be how much? It is 4. So definitely the average would be some around 6 volt, and this change is how much? It is 2. So the modulation index, what we shall say here, this being how much? 2 it is, and 2 divided by 6, it is 1 by 3. So for question number 19, option 2, that is 1 by 3 is the correct answer. Now proceed to question number 20. In question number 20, the pitch of a screw gauge is 0.5 mm and its cap is divided into 100 division. When this screw gauge is used to measure the diameter of wire, the main scale reading is 3 and 40th division of circular scale coincides with the main scale. If there is no zero error, the diameter of the wire is. We have been provided with the screw gauge with the 0.5 mm as the pitch length, and that is further divided into 100 division. So least count would be 0.5 divided by 100. This is the least count of the system. So while taking the reading, main scale reading is 3 and the 40th division matches with the main scale. That means it is 0.5 divided by 100 into 40th. This would be the reading. Taking the proper care of the significant digits, that's been based on the pitch length or the least count of the screw gauge system, we shall be saying this part to be 3.200 mm. That's the final answer for the question number 20. Option 4 is the correct answer. Now let's proceed to question number 21.